Hello, my dear students. Very good afternoon. How you all are doing? Today I'm back with yet another extensive session on thermodynamics important problems on Unacademy platform, my dear students. And on this beautiful occasion, I would like to go ahead with some of these interesting concept based problems, I would like to say, rather. Okay, and these concept based problems are definitely going to help you in a long run. Okay, I want each one of you to go ahead and say, Unacademy, let's crack it. Let's crack Unacademy platform based problem solving. Okay, so let's go ahead and beat the problems. Let's go ahead and not to be worried at all regarding the problems, because Unacademy always keeps on saying let's crack it. Okay, so hence today afternoon, this beautiful afternoon, we are set to go on a long road of thermodynamics. Okay, so important problems. So I would like to hear good afternoon from each one of you. Very good afternoon to everyone. Hope you all are doing fabulously fine. Ananya, very good afternoon. Yes, that's it. That's it. That's great. Prasanna, Uday, Deepa, very good afternoon. Welcome to our YouTube session of Unacademy, and here we are with the progress on thermodynamics problems, my dear students. Important problems on thermodynamics. Okay, so this is our goal today. So I'll be continuing with the problem solving. In the previous session, I had covered 8 good number of problems, right? So today we'll take a look at few more interesting problems on thermodynamics. Let's progress. Okay, fine. So this is my profile for your perusal. My name is Uttam Kumar Umarji. In fact, this is my 19th year in teaching, my dear students, and with my experience of 19 years, I have taught to lot many number of students all across the country. And in fact, I love physics, and I love teaching physics to the students, and physics happens to be my in-depth core. Okay, so definitely, my dear students, with this note, today you will learn the good quality problems for next half an hour. So are we all buckled up? So let's progress with the solutions to the numerical problems on thermodynamics. Okay, and presently I'm enjoying number 2 position in Karnataka CET, my dear students, and we can move ahead with our discussion. So here, this is my brief experience. I've taught JW Advanced, JW Main Physics for 19 years at Delhi, Kota, and Bangalore, as well as all across India, pan India. And with this particular beautiful note, I would like to say I have taught closely to 10,000 plus students till date. Okay, and I know you are one among those 10,000 students who are attending these sessions. So thank you for being my students. And currently I'm working at Prarthana PU College in Bagalkot, and this is my third month. Third month is almost over now. Okay, so this I can say I have completed 3 months on an academy. That is, let's crack it, my dear students. Okay, so with this note, now let me just move on to what an academy offers to each one of you. It offers one of the highly beneficial thing called plus subscription. And an academy plus subscription, it tells you regarding some of the beautiful plans. Okay, you can go ahead and take a look at Karnataka CET 2021 aspirants for you. These are the plans, my dear students. So first plan, this is a 12-month plan, okay, and it costs you 12,375 rupees. That is approximately around 1,031 rupee. You can go ahead and make a payment as an EMI, okay. So there is an EMI facility here. Then a 6-month plan which costs 10,125 and an easy monthly installment of 1,688 rupees can be availed as well. Okay. Then we have, suppose you would like to take a look and would like to try Unacademy platform for say 1 month. Okay, you are good to go with that. So if you are a first time subscriber, then you can go ahead with this trial plan, okay, which is 1 month plan, which would cost you 2,250 rupee for 1 month. This is only for new subscribers, my dear students, okay, and these prices are supposed to get changed in next academic year. So definitely this is the advance chance that you have. Go ahead and grab it, my dear students. And what you will get out of it premium content at a very reasonably affordable price, structured live courses, dedicated live doubt clarification sessions you will get. Then quizzes are conducted at regular intervals for self-analysis, then batches for complete preparation, test series for DPPs you have, then full length mocks you will get with analysis. That is most important. So all in all, I would like to say single subscription for unlimited access. That is Unacademy's promise, my dear students. And definitely you can be a part of a live batch for your complete syllabus preparation. Okay. So, in order to avail a 10% discount, my dear students, on your subscription, you can go ahead with UTTAMLIVE. Okay, so with this code, you can avail this offer of 10%, my dear students. Okay, go ahead and grab this opportunity. Never ever be left behind. Okay, so now let's progress to the problems, my dear students, quickly. Hope you all are ready for it. Now, I would like to hear, are we ready, my dear students? Yes, I would like to hear from you. I'm looking at the chat box now. Are we ready, my dear students? Yes, come on, come on. I would like to hear you saying, are we ready? Yes, okay. Yes, thank you. Thank you, Ananya. Okay. Yes, BG. I don't know what is the long form. BG, thank you. Prasanna, thank you for confirmation. Now let's progress with our session now. Now the first question, it reads as two identical containers A and B with frictionless pistons contain the same ideal gas at the same temperature and the same volume. The mass of the gas in A is Ma and that in B is Mb. The gas in each cylinder is now allowed to expand isothermally to the same final volume. The changes in the pressure in A and B are found to be delta P and 1.5 delta P respectively. Okay, then so we should find a relationship between MA and MB. By looking at the options, we can understand what is required to be found. So here we are supposed to find the relationship between MA and MB, right? So let's go ahead and take a solution to this. So as we know that the process is isothermal, so that means temperature is constant. So if temperature is constant, my dear students, then we can say P is inversely proportional to V. That means volume is increasing, thus pressure will decrease definitely, because in the problem they have given that volume is increasing. So definitely there will be what? Decrease in the pressure. And if there is a decrease in the pressure in chamber A, what happens? That we will consider here. So in chamber A, I can write delta P is equal to Pi minus Pf. Okay, and what is Pi? Pi is mu A RT divided by V, right? Whereas final, it is what? Mu A RT divided by 2V, because volume has increased to 2V now, right? So definitely if we just take a look at this equation, we can say that it is 1 minus 1 by 2 kind of thing. So we can write it as what? Mu A RT by 2V. Okay, so this is first equation we are obtaining, my dear friends. Okay. Now in chamber B, in the same way, in chamber B, now 1.5 delta P, because pressure they have given in chamber B as 1.5 delta P. So hence I am writing it as 1.5 delta P is equal to Pi minus Pf. Okay, and initial pressure is what? Mu B RT divided by V minus final pressure mu B RT by 2V here. Okay, so thus mu B RT by 2V, if we just subtract it from mu B RT by V, we'll get this as mu B RT divided by 2V. Now this is my second equation, dear students. Okay, so accordingly, from first and second equation, I can very easily see that I'll get mu A by mu B is equal to, because as you can see left hand side will get cancelled off. Okay, and here delta p will get cancelled, so we'll get this as 1 by 1.5 on left hand side, and on the right hand side we'll get what? Mu A by mu B, right? So equations 1 and 2 I'm dividing, so thus I'll get this as 1 by 1.5 is 1 by 3 by 2, which is 2 by 3 here. So accordingly now I can write number of moles is equal to what? Mass divided by molecular mass, is it not? So hence Ma divided by molecular mass, Mb divided by molecular mass, and the ratio is what? 2 by 3. Now as you can easily notice here, we tend to see that here molecular mass cancels off. Since molecular mass cancels off, we'll get Ma by Mb is equal to 2 by 3. That means if I just cross multiply, I'll get 3 Ma is equal to 2 Mb. So this is what we are supposed to get now. So this is the initial requirement for the problem. So we have found the relationship between Ma and Mb. So obviously the option is C here, is it not? Good, very good. Now, shall we move on now? Let us move on to the next question quickly. Question number 2. Okay. Now, question number 2, what it reads? An ideal gas expands isothermally from a volume V1 to V2 and then compressed to original volume V1 adiabatically. Initial pressure is P1 and final pressure is P3. The total work done is W. Then, okay. So look at the options. Now, all the options are connecting P3 and P1, and they are commenting whether work is positive or negative. Either of these things, or work is 0. So that we should check. Now, according to the given situation, what we'll do is we'll draw a PV diagram here. Okay. So as you can notice here, we'll draw a PV diagram. Now here, this is a PV diagram. So AB process P1 to P2. Okay. And CB, along CB, if you just take a look, the process direction is B to C here, right? So process direction is BC. So hence here initial pressure P2, from there it increases to P3, and over here as you can see, AB process is expansion, BC process is compression. Okay, so this is one thing that you can notice out of this PV diagram. So I hope it is clear. Okay, so now accordingly, next step what I will do is we can clearly understand that pressure P3 is greater than P1. As you can notice, P1 at point A, at state A is lesser than P3. So therefore I can say P3 is greater than P1. Okay. So thus I can write this as what? Since area under adiabatic process, that is BECD or BCED, is greater than that of isothermal process ABDE. Now take a look at the areas now. Okay. So if you just take a look at area AEDB and area CEDB, okay, or BCED, then we tend to see that this area BCED is larger under this graph. As you can notice, this graph has larger area than this graph. That graph is ABDE, right? So accordingly, I can comfortably say that net work done, it must be what? W equal to W isothermal plus minus of W adiabatic. Why am I writing it as negative? Because adiabatic process is compression process now. So in compression, work done is negative. So therefore minus of W adiabatic I'll write. So from this, and second thing, we know that W adiabatic is greater than W isothermal. So that means negative value is larger than positive value. So hence we must see that net work done will be negative here. That means it will be less than 0. Is it not? So hence from this I can comfortably say that P3 is greater than P1 and W is less than 0. That means our option is option C here. Is it not? Okay. So option C is our right choice that we have obtained, my dear students. Okay. Now let's move on to third question. A closed hollow insulated cylinder is filled with gas at 0 degrees Celsius and also contains an insulated piston of negligible weight and negligible thickness. At the middle point, the gas on one side of the piston is heated to 100 degrees Celsius. Okay, if the piston moves 5 centimeter, the length of the hollow cylinder is. Okay, now this is a very interesting question that we have here. So as you can notice, closed hollow insulated cylinder is filled with gas at 0 degrees Celsius. Okay, and also contains an insulated piston of negligible weight and negligible thickness at the middle point. The gas on one side of the piston is heated to 100 degrees Celsius. And lastly, they say that if piston moves 5 centimeter, then the length of hollow cylinder is how much? Okay, fine. So over here, firstly, we'll use Boyle's law here. According to Boyle's law, V by T is equal to constant, we can say, right? Then as the piston moves 5 centimeter, the length of one side will be what? L by 2 plus 5 and the other side would be what? L by 2 minus 5. Okay, so thus if capital A is area of piston, then we can comfortably see that now area into length is what? Volume, right? So volume by temperature I am writing. So here V1 is what? L by 2 plus 5 into A, that is V1, divided by what is T1 temperature? 373. That is on left hand side we have 0 degrees Celsius, remember. So right hand side, I'm sorry, on the right hand side the temperature is increased to 100 degrees Celsius, which is 373 Kelvin here, right? Similarly, that must be equal to what? Here V2 is what? L by 2 minus 5 into A, that is V2, divided by temperature T2 is what? 100 degrees Celsius, right? So thus I am considering 273 Kelvin here. So accordingly, if you just simplify this equation, we will get L is equal to 64.6 centimeter. So this happens to be option D here, my dear students. Okay, I hope I'm clear on this part. Now let's move on to fourth question quickly. The molar heat capacity in a process of diatomic gas, if it does a work of Q by 4, when heat of Q is supplied to it is. Okay, so they have asked us to calculate molar heat capacity. So molar specific heat we should find here for a diatomic gas. So accordingly, du internal energy, I know that du by dt is equal to Cv, right? So hence I'll write du is equal to Cv into dt. And remember, for diatomic gas, Cv is how much? 5 by 2 R, right? So hence I'm substituting for diatomic gas, Cv is equal to 5 by 2 R into dt. Or in other way, I can also write it as what? dt is equal to 2 into du by 5R. So this is my first equation here. Then from first law of thermodynamics, I can say that du is equal to dq minus dw. Is it not? Yes. Okay. So hence I can write from first law, because first law it gives the equation as q is equal to w plus u, right? So accordingly, du will be equal to what? dq minus dw, and here dq is given as what? Q, and dw is given as q by 4. That is, the work done is q by 4. So thus we will obtain this as what? 3q by 4. Correct? Okay. Then now hence molar specific heat capacity, C is equal to what? dq by dt. Okay. So thus this is q divided by what is dt here? Dt is 2 du by 5r. So I am just substituting that 2 du by 5r. So accordingly, this 5r comes to the numerator here. So thus I will get this as 5rq divided by 2 into 3q by 4, because du is 3q by 4. So I am just substituting that. So accordingly, I can see that here I can cancel off q here. Okay, then I can cancel 2 ones are 2 twos are here. Then this 2 comes to the numerator, it becomes 10, right? So 10 divided by 3 into R. So 10 by 3 into R is molar heat capacity for that particular gas. Okay, so our answer is option C here. Okay, are we clear on this, my dear students? Shall I progress now? Fine. Now, fifth question. The fifth question, it reads as: a Carnot engine working between 300 Kelvin and 600 Kelvin has work output of 800 joule per cycle. Okay, what is the amount of heat energy supplied to the engine from source per cycle? Okay, so Carnot engine working between 300 Kelvin and 600 Kelvin has work output of 800 joule per cycle. They have given this. Okay, so we should find amount of heat energy supplied to the engine from source per cycle. That's all. Okay, so here we'll make use of Carnot's principle. Okay, so eta is equal to T1 minus T2 by T1, that is equal to what? W by Q here. So accordingly, Q becomes equal to T1 divided by T1 minus T2 into W, right? So therefore, I can write this as 600 by 600 minus 300 into 800. So this is obviously 300, 300 ones are 300, twos are will get. So 2 into 800, that is 1600 joule, and 1600 joule is present in option D, my dear students. Okay, fine. Now let's go ahead with problem number 6. Okay, now the sixth problem, what it reads as: An ideal gas heat engine operates in a Carnot cycle between 227 degrees Celsius and 127 degrees Celsius. It absorbs 6 into 10 raised to 4 joule at high temperature. The amount of heat converted into work is. I'll make use of efficiency equation. Okay, so 1 minus T2 by T1 is eta here, is it not? That is 1 minus 400 by 500, that is efficiency will be 500 minus 400, that is 100 divided by 500. Thus I can write the efficiency as 1 by 5 here. Okay, then as eta is also equal to what? W by Q. So therefore 1 by 5 is equal to W by Q, I'll write. So accordingly W can be written as what? Q divided by 5, which is 6 into 10 raised to 4 by 5. So that should give me the value as 1.2 into 10 raised to 4 joule. So this is option D that we have, my dear friends. Now, seventh question. A Carnot's engine used first an ideal monoatomic gas, then an ideal diatomic gas. If the source and sink temperatures are 411 degrees Celsius and 69 degrees Celsius respectively, and the engine extracts 1000 joule of heat in each cycle, then area enclosed by the PV diagram is. So that means we should find what? We should find the work done, is it not? So first we'll find efficiency. Okay, according to Carnot's principle, eta is equal to 1 minus T2 by T1, that is 1 minus 273 plus 69 divided by 273 plus 411. So obviously if you just add this up and simplify it, we'll get the value as 0.5 here. Okay, so thus I can write next step, work done is equal to efficiency into heat, is it not? So efficiency is 0.5 here, so 0.5 into 1000, that should give me the value as 500 joule, and 500 joule here, my dear students, it is option C, is it not? Then eighth question now. A Carnot engine absorbs an amount Q of heat from a reservoir at an absolute temperature T and rejects the heat to a sink at a temperature of T by 3. The amount of heat rejected is. So we should calculate the amount of heat rejected to the sink. That's all. Right. So over here, now we know efficiency eta is equal to 1 minus T2 by T1. That is nothing but what? Work done by heat input. Correct. So W by Q1 is also efficiency. So hence I am just writing equal to W by Q1 here. So accordingly, now T1 I am taking it as T here, and T2 it is T by 3 as per given. Right. Then we can see that Q1 is heat absorbed, Q2 is heat rejected. If I consider like that, then 1 minus T by 3 upon T is equal to W by Q1. I can write like this, is it not? Now, obviously, T can be cancelled out from this particular equation, right? So here T goes off. Thus, we are left with 1 minus 1 by 3, which is 2 by 3 here, right? 2 by 3 equal to W by Q1. That is equal to W is what? Q1 minus Q2, is it not? W is Q1 minus Q2, so therefore Q1 minus Q2 by Q1 I'll write. Then from this I can comfortably write this as what? 2 by 3 is equal to 1 minus Q2 by Q1. This equation I'm modifying it like this. Okay, so 1 minus Q2 by Q1 you will get. So therefore Q2 by Q1 will be equal to what? 1 by 3. Very simple, because this is Q2 by Q1 I am shifting on this side. Okay, then 2 by 3 I'll bring it here, then I'll get Q2 by Q1 equal to 1 minus 2 by 3. 1 minus 2 by 3 is 1 by 3 here. So therefore Q2 is equal to, I'll get this as what? Q2 is equal to, I'll just erase this. Okay. Now Q2 is equal to what I'll get? Q1 by 3. And Q1 is Q here. So hence I'll write this as Q by 3. That is option B here. Okay. So dear friends, with this particular note, I'm just planning to sign off for the day. Okay. Now the time is up. So let us go ahead and end with this session, wind up with this session. Okay. I'll see you back on 1st January. 1st January, I'll be coming back with many more questions, many more interesting concepts on this Unacademy YouTube platform. Okay. Until then, your teacher Uttam Kumar Umarji, I say sign off. Thank you very much. Have a wonderful time ahead. I'll see you back on 1st on YouTube. Okay, next year. Thank you. Have a fabulous time.